Yes, today I would like to talk about integration by partial fractions. So, first of all, when do we do integration by partial fractions? So, we do integration by partial fractions when we have to find the integral of a rational function f of x over g of x, where let's say the degree of this is n, the degree of the numerator is n, and the degree of the denominator is m. So and n has to be less than m. Or we can bring it to this form by, of course, division of polynomials. How we do this? What we do is we break the so let's say the how. So we break the denominator into product of linear and quadratic factors. I mean, every polynomial can be break down into product of linear and quadratic factors. I mean, the quadratic factors, they have to be there if the discriminant of the quadratic is negative. So in this case, in the set of real numbers that we are working, we have no roots, so it has to stay as a quadratic. So we break this into a product of factors, and then we equate this rational function to be equal. So what we do is we break this into let's say this denominator here is equal with ax plus b times c x squared plus dx plus e, and let's say this is to the k, maybe not k we have here, yeah, let's say this is to the k and this is to the l. So we have to write every linear factor with just a constant above, so ax plus b, but you have to include all the terms. Like let's say if it was ax plus b to the second power, you have to write this here plus b to the ax plus b squared. If it was to the third, you should write another term plus c over ax plus b to the third. And then, so this is for every linear factor, and for every quadratic factor you do exactly the same, but now in the numerator you write, let's say, capital C x plus d over lower x plus dx plus e. And again, let's say if this was to the third power, then you have to write plus, like cdx plus f over this here to the square plus another one to the third. So, and then you have to try to find all these constants, a, b, c, d, etc. And then you continue from there. It's very easy, and you can find the integral. So now the only let's say formula that you will need, it will be the formula that the dx over x squared plus a squared dx. This is equal with 1 over a times the inverse tan of x over a plus c, of course, since we are talking about infinite integral. So that's all. So now let's go and do some problems. So I will start from this problem here. So here what we have to find the integral of x minus 9 over x plus 5 times x minus 2. So what we do here, we said here we have two linear factors, so we go and we try to write this here. Let's forget the integral for a minute and let's just work on the x minus 9 over x plus 5 times x minus 2. So, as I said earlier, both these are linear factors, so we have to write this as a over x plus 5 plus b over x minus 2. And of course, what we're trying to find here is the a and b. I mean, that's not a big deal. We just cross multiply, so we get the same denominator. So that should be a times x minus 2 plus b times x plus 5 over x plus 5 times x minus 2. And now you just have to do a little bit calculations here. So we have ax minus 2a plus bx plus 5b, and of course the denominator stays as it is. And now if you group this, we have ax plus bx, so we can write it as a plus bx, and here we have plus the minus 2a plus 5b. So, and of course the denominator stays always the same. So in order for this to be equal with this, because it's the same thing, what we have to do is we have to make sure that the coefficient which is before the x, which is a plus b, is equal with the coefficient here, so which is equal with 1. So what we have to find, what we have to say that a plus b has to be equal with 1, and this here, which is the constant, has to be equal with minus 9. So minus 2a plus 5b is equal with minus 9. So that's about it. And so we just have to find a and b, which is very simple. Let's erase a little bit, and we can erase this. So, I mean, let's say if we multiply the first one by -5, we will get that -5a negative 5b is equal with -5, and of course we write the rest, the second one, so minus 2a plus 5b is equal with -9. So if you add these two cancels, and we have that minus 7a is equal with -14, and of course that gives us that a is equal with 2. And yep. And now if you go to one of these two equations of the system, let's say we'll go to the first one, which is easier. You substitute wherever a equal with 2, and you get that b should be equal with 1 minus 2, so that should be -1. So that's it. So we find that a is equal with 2 and b is equal with -1. So you just go here and you put these numbers, and we are done with this part. So we set a is equal with 2 and b is equal with -1, so we'll put minus here and 1 here. So, and now we can go and find our integral, which is as follows. Now instead of having to find the integral of this, we have to find the integral of this. So, and of course, here we have to put dx, and so that means that we have to break this into two integrals, and of course because I mean this is again something either you can do it by substitution or like it's easy to remember, so usually we do it directly. So the integral of this here, it should be 2 ln of x plus 5, and the integral of this, it will be ln of x minus 2, and of course plus c, since we are talking about an infinite integral. I mean, this is very easy. I mean, if you don't remember it, it's pretty easy to do it just by substituting wherever u equal with x plus 5, and you find this here. So, but it's pretty easy, and at this level I believe you should know it by heart. Now, let's do another one. Find the integral of x to the third minus 4x minus 10 over x squared minus x minus 6. So, I mean, here, as you see, the degree of the numerator, it's 3, and the degree of the denominator is 2, so it's the degree of the numerator is greater than the degree of the denominator, so that's why we have to do first the division of polynomials. So let's do the division of polynomials. So here we put the dividend, which is x to the third, plus, we have to put all the powers of x, because here the x squared is missing, so it should be plus 0x squared minus 4x minus 10, and here we put the divisor, which is x squared minus x minus 6. And now, what you do is you divide the first term of this with the first term of this, so x to the third over x squared is x, and now you multiply this with this and you subtract from here, so x times x squared is x to the third, so with the minus it's minus x to the third, x times minus x is minus x squared, with the minus is plus x squared, and x times minus 6 is minus 6x, with the minus is plus 6x. So, and now you add, so of course this cancels with this, and here we have x squared plus 2x minus 10. So we continue the division, and now of course you divide this, the first term of this, which is x squared, with the first term of this here, which is x squared, so that should give you plus 1. And now you multiply this with this and you subtract, so 1 times x squared is x squared, with the minus is minus x squared. 1 times minus x is minus x, with the minus is plus x. And 1 times minus 6, with the minus is plus 6. So this cancels with this, and you have 3x plus 6. And here we stop, because when we stop the division of two polynomials, we stop when the degree of the remainder it's less than the degree of the divisor. Of course, here this is the remainder, so of course it's of degree 1 and this is of 2, so that's why we stop. So what we have done, we divided this polynomial, so x to the third minus 4x minus 10. So this is equal with this times this. Plus the remainder. So let's write it here. Like, what I'm doing here just to make sure that you understand. So let's say you have 27, you divide it with 5. Of course, it gives you 5, and the remainder 2. So that's why you write 27 equal with 5 times 5 plus the remainder. So it's like the analogy from numbers to polynomials. So you always write the dividend equal with the divisor times that what you find plus the remainder. So just to make sure that you understand what I'm doing. Now we have this here. So in order from this, in order to create this here in this equation, what we do is we have to divide everything by the denominator. So you divide this by the denominator. So, but of course you have to do the same here. So we can break it down. So of course, this cancels with this, and that gives us that all this is equal with x plus 1 plus 3x plus 6 over x squared minus x minus 6. And of course now we want to find the integral of this, so we said that this is equal with this, So instead of finding this integral, you just have to find this integral. Of course, to find the integral of this here is pretty easy. It's x squared plus x. And now for this here, again, you have to break this into, you have to use partial fractions, what actually we're doing today. So you have to break this, let's say if this here has, what is the discriminant? So the discriminant here, it's b squared, so it's 1 minus 1 squared, which is 1, minus 4 times 1 times minus 6, so it's plus 24, so 1 plus 24 is 25, so it's positive. So that means that we can break this down. There are many ways. We can do it by breaking this here down. So we can write this as minus 3x plus 2x minus x, and of course minus 6. So now by grouping, let's say we take these two, you take out x as a common factor, so that's x plus 2, and from this to the minus 3, so this x plus 2, so that means this is equal with x plus 2 times x minus 3. So that means that this here, the 3x plus 6, you can write it as 3. The numerator you can write it as 3 times x plus 2. And the denominator, it's x plus 2 times x minus 3. So you see that this cancels with this. And of course, what you have just what it stays, what remains is the 3 over x minus 3, which of course the integral of this, it's the ln, it's 3 ln of absolute value of x minus 3. Now, let's do one that has quadratic inside. So let's do the following. So we have x to the third plus x squared plus 2x plus 1 over x squared plus 1 times x squared plus 2 dx. Always you have to check that the degree of the denominator is greater than the degree of the numerator, otherwise you have to do the long division. So here it is indeed, the degree of the numerator is 3, the degree of the denominator is 2 plus 2, it's 4. So we're good to go. So that means that we have to do partial fractions, and here you see that in the denominator both terms are quadratic, that cannot be brought down because like these two quadratics, the discriminant is negative. So okay, so that means that you take this here, you forget about the dx for a minute, and you have to break it down. So we said that if they are quadratic, it has to be equal, and forget the dx for a moment, just working on the rational functions. So we have to find ax plus b over x squared plus 1 plus let's say cx plus d over x squared plus 2. So need the brackets here. So, so again, we have to find A, B, C, D. Okay, so again, we have to we have to put everything under the same denominator, so we multiply this with this. So we can do it directly, I believe that. So we multiply all this with this. So ax times x squared, it should be ax to the third. Ax times 2 will be plus 2ax. Now, b times x squared is plus bx squared. And 2 times b is plus 2b. Now we multiply the x squared plus 1 times the cx plus d. So that should be cx times x squared, it should be plus cx to the third. And cx times 1 is plus cx. And then then cx times 1 is plus, sorry, we got this. So now we have d times x, where is dx squared? And d times 1 is plus d. So now we collect like terms. So we have ax to the third and cx to the third. So that should be, we'll put everything also, we'll take the common factor, which is x to the third. So that should be a plus b, x to the third. So let's cross them out. Now you have, let's say, bx squared and dx squared, so that should be plus b plus d x squared. Cross them out. And then we'll have the ones with the x, so that should be plus 2a plus c times x. And finally we'll have the constant, which is 2b plus d. So, and of course, the denominator, it will remain the same, which is this here. So in order for these two to be the same, the numerators have to be the same, which is, this and of course this. So, and again, it's the same thing. You have to equate the coefficients. So the coefficient here before the x to the third is 1. So that means that the a plus b, which is the coefficient here of x to the third, so you have that a plus b has to be equal with 1. The coefficient before the x squared is 1, so that means that you have that b plus d is equal with 1. Now, the coefficient before the x is equal with 2, so you have that 2a plus c is equal with 2. And finally, the coefficient before the constant is 2b plus d, so that means that 2b plus d has to be equal with 1. So we have 4 equations with 4 unknowns. So that means that we can find